Hey everybody, Mr. Elliott here. How you doing today? Hopefully you're watching this on either Sunday night or Monday in class. And what we're going to be doing is we're going to combine our skills from the last couple days. We had our law of sines, and then we did our law of cosines, and now we're going to be using both law of sines and law of cosines in the same problem to completely solve triangles. I only have one example for you, but I have a lot of just little things I got to talk about because these problems have a lot of details. And I think it's better to just do one example and then let you just kind of practice here on your own and kind of learn these things just while practicing the problems. Here is this is a side angle side equation, but whenever you solve triangles, I always like to set it up by just writing, like this is where my answer is going to go. So I have A, B, C, and little a, little b, little c. And according to all this, angle C equals 42 degrees. Side B is 5 feet, and side A is 7 feet. So I need to find these three things. Now, this triangle is a side angle side triangle. So because it's side angle side triangle, you need to start with law of sines. Meaning I'm going to go hunting for this, or not, I said law of sines, but what I meant to say was law of cosines. Sorry about that. And when you're going to use law of cosines, if you're doing the side, the angle of the side, because this is the angle that I have, you're going to be hunting for the side opposite it. So, c squared equals a squared plus b squared, 7 squared plus 5 squared, minus 2 times 7 times 5 times cosine of that opposite angle, which is 42 degrees. And then c is equal to the square root of all this stuff. Which I then put into my calculator to get a decimal approximation. And I actually already did this problem over here, so I just to save time, this works out to be 4.688, which I put up here, 4.688. Now I need to go and figure out side A and side B. And you have a couple options. Now that you have all three sides, you can use law of cosines if you want. Or because you have all the sides in one of the angles, you could use law of sines. And if you think about the two equations, law of sines is definitely easier to use. But because this is the normal lesson, I need you to just trust me and follow these two pieces of advice when it comes to side angle side triangles. And it's this. In a side angle side triangle, never use law of sines. If you never use law of sines, bad things will never happen to you on these problems. Just stick with law of cosines. It is more work, but you only have to think about using law of cosines, and as long as you're good with law of cosines, you're good. Or you could first use law of cosines to find the missing side. That is exactly what we've done in our work so far. Then use law of sines to find anything but the largest angle. The one, in my opinion, that uses less thought is rule A here that says to never use law of sines. So I'm going to finish up this problem using just law of cosines again. So in that, because I'm looking for angle B or angle A, you could pick either one. Which one do I want to pick? I guess I'll go hunting for angle A because A comes before B. So if I'm going to be using this, looking for this angle, I'm going to use this side. So 7 squared equals, it needs to be the other two sides squared, so 5 squared plus, now this is a decimal approximation, and I need to use the exact. So instead of writing all this out, I'm just going to say all of this squared. Minus 2 times 5 times this stuff times cosine of the angle that's attached to 7, and that's cosine of A. All right. Next, subtract this from both sides, divide both sides by that. So I have 7 squared minus 5 squared minus that stuff squared divided by negative 2 times 5 times that stuff equals cosine A, which means A is equal to cosine inverse of 7 squared minus 5 squared minus that stuff squared, all divided by negative 2 times 5 times stuff. And that gives me the exact. And then from there, I could use, I could plug all this into my calculator using the approximation. Now this stuff, to keep it exact, because the last thing I did with my calculator was get this as an approximation, my calculator should read 4.68 blah 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 throughout that entire thing. So at that point I can now put this into my calculator by going cosine inverse of 7 squared minus 5 squared minus answer squared divided by negative 2 times 5 times answer, close. I'm going to show that entire thing right now with this calculator. So I have to go back to here. So I have square, oops, clear that, square root of 7 squared plus 5 squared minus 2 times 7 times 5 times cosine 42, close parentheses, and I got a value of the 4.688. Now my entire screen has that exact value, so now I'm going to use that exact value to solve this stuff out. So it's cosine inverse of, open a new set of parentheses for the numerator, 7 squared minus 5 squared minus answer squared, so use the answer button, squared, close numerator, divided by, open denominator, negative 2 times 5 times the stuff, so times the answer, close denominator, close cosine inverse, hit enter, and I get an answer of 92 point, if I'm going to 3 decimal spots, 470 degrees. So way up here at the top, A is 92.470 degrees. And then if I go 180, so I have 180 degrees minus 92.470 minus 42, and that gave me 45.530 degrees, and that's my answer. Okay, now let's go back to the advice that Elliot was talking about. Never use law of sines, or first use law of cosines to find the missing side, which is what I did, then use law of sines to find anything but the largest angle. So I used kind of technique A here to never use law of sines, but what if you decide to not follow Elliot's advice? What if you're like, well, I'm going to use law of sines to find that last couple angles because it's significantly less work? Let's look at that. Let's say you did not follow my advice. So we got to here, we got this point that we have side C. We know that side C is 4.688. For the rest of this example, I'm just going to use 4.7 feet so I can write a little bit less. So then let's say I decide to use law of sines, and I use law of sines to find angle B. So I go sine of 42 divided by 4.7 equals sine of B divided by 5. I cross multiply, I divide, I do the sine inverse, I end up getting 45.4. So angle B is 45.4 degrees. And then I do that 180 minus, I add these two up, and I go 180 minus that, and I get 92.6. Okay, degrees. That's actually the same answer I got earlier, so seems reasonable. But that was because that was when I found angle B first. What if instead I would have found angle A first? So I didn't do it this way, I did it this way. Well, you end up getting sine of A equals all this. You sine inverse it, you get 85.3 degrees. So A is 85.3 degrees. And then I do the 180 minus the sum of those two, and I get 52.7 degrees. Hold on. I did the same work, but I got two different answers. Uh-oh, how do you know which one's right? You didn't follow Elliot's advice. Let's go back to Elliot's advice. Elliot says, use law of sines to find anything but the largest angle. Which angle's the largest? It's the angle opposite the longest side. So when you look through this triangle, the longest side is the 7 feet. So the 7 feet should give us the largest angle. But when we look at this largest angle, they're not matching up, but it is the largest angle in either case. All right, well, the medium-sized side should give the medium angle. Okay, well, yeah, and then the smallest side should give the smallest angle. How do you know which answer is right? I don't know. I don't know which answer is right, to be perfectly honest with you. And that's because I didn't follow the advice. And the advice was, once again, only use law of sines to find anything but the largest angle. And when I look at this example here, I used law of sines to find the largest angle, which was the big no-no. You can't do that when you're using law of sines. So you'd get rid of this one, so this is the only answer. If you think about to the original problem, it was a side angle side equation, so there can only be one solution. So at the end of the day, when we got two solutions, you had to get rid of one of them, and in this case, you're getting rid of the one that had the smaller, that you did not find the largest angle first. So if you're doing the normal lesson stuff that I've talked about, you need to follow this advice. So let's quickly review Elliot's pro solving triangle tips. Side, side, side. Smartest thing to do, never use law of sines. If you never use law of sines, it's never going to be a problem. If you decide you really must use law of sines, then first use law of cosines to find the largest angle. Once you have that, nothing weird's going to happen. It's then okay to use law of sines on the next angle. Okay. We already talked about the side, side, side situation. Angle, side, angle, 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 side, nothing weird about that. Just use the triangle sum theorem to find the missing angle. Then you can safely use law of sines for everything else. The only time we have issues with law of sines is when you're looking for angles using law of sines. This is the normal lesson, so I'm not even going to talk about the advanced stuff. But if you get a side-side angle or an angle-side-side triangle, ha ha ha, use law of sines to find the missing angle. You're kind of stuck with that. Use triangle sum theorem to find the final angle, and then use law of sines for the final side. That's the easiest way to do it, and Elliot promises those problems will always work out normal for you, and you won't have anything to worry about. Just to talk about a couple of the pitfalls that happens with these. The first one's involving a side, side, side. And a side, 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 I mentioned never use law of sines or use law of cosines to find the largest angle. Here's Elliot not following that advice on a side, oh wait, talking side, side, side problem. So here's a side, side, side problem that I have a 6, a 7, and a 12. And I decide to use law of cosines, but I decide to not use law of cosines to find the largest angle I used law of cosines here to find angle x, which if you look at this, that's actually the smallest angle. So I work that out, I get 21 degrees. And then I do the same thing I did before. I use law of sines to find, I still need to find w and m. So let's say I use law of sines to find angle w. That would end up being 46 degrees. And then triangle sum theorem, angle m would end up being 113 degrees. These are both approximates. But what if instead of doing law of sines to find w, I did law of sines to find m? So sine of 21 over 6 is equal to sine of m over 7. M in that case works out to be 25 degrees, and w works out to be 134 degrees. So I got, in one hand, m was this, on the other hand, m was that, or w is this, or w is that. It gets really confusing, and that's because you didn't follow the advice. So trust Elliot, only don't use law of sines. This problem I hit a problem when I started using law of sines. I got different answers. If I would have used law of cosines up here and found the largest angle, then law of sines would have been okay. But the biggest mistake here is this person, me, didn't use law of sines to find the largest angle. One more issue with side angle side. Actually, I don't need to show you this one because this issue is the same as what happened in the example that we had. So, yeah, so be really careful when solving these. You got to make sure to follow these pro tips, and as long as you follow these pro tips, these problems will work out for you. I'll put a copy of this on my website. All right, everybody, that's all I have for you. If anything on this lesson was confusing, please ask me about it. I want to help you out, but I can only help you out sometimes if you ask me questions, because I can't read minds, so I don't really know what your questions are. I can kind of predict, though. Anyway, have a great day, and I'll talk to you later. Bye-bye.